Hi, everyone. My name is Judy Higgins, and I welcome you to Using Thinking Moves to Reach Deeper Scientific Understanding. I have been a teacher for close to 20 years, and learning about thinking moves was one of the most transformative steps in my teaching career. So let's start with our goal. I love this quote. The object of teaching a child is to enable him to get along without a teacher. Now, I haven't gotten there yet. However, I do not work nearly as hard as I used to. And I'm definitely not the only one in the room doing all the thinking. So let's take a look at how we're going to get to that goal and what are thinking moves. So this is a list of thinking moves, and this was developed by a team who have learned a lot about thinking, and they actually wrote a book called Making Thinking Visible, which is something that I use a lot. Enjoy, whether it is acting as a parent, which many of you are out there, a teacher, a principal, a coach. You will all really grow by learning about thinking moves. And if you're a principal or a coach, watching those teachers who are using thinking moves and watching the way thinking moves are those moves that accelerate understanding to really get to deep, productive understanding. So there are 8 thinking moves that I'm going to talk about today. And for each thinking moves, I'll give you examples, most of which come from things that went on in my classroom. So the first one is observing closely and describing what's there, building explanations and interpretations, reasoning with evidence, making connections, considering different viewpoints and perspectives, and capturing the heart and forming conclusions, wondering and asking questions, and uncovering complexity and going below the surface of things. You'll notice that these go along very well with the next generation skills, science and engineering practices, which was why this was so exciting to me as a science teacher to see how closely connected these are. Okay, so let's talk first about observing closely and describing what's there. So for those of you who are not No-Atom teachers, this is what a No-Atom reader looks like. So we first start by asking our students to observe. Take a look at this picture, because understanding is propelled by noticing parts and features. So when you ask a student to observe and take note, here are some quotes. I noticed that bird seems to be eating something from the flower. The wings in the picture are blurry, so I think that they're moving really quickly. Great observation. I wonder how that bird stays up in the air, even though it has stopped to eat. What a great wondering. What a lot of questions that student has in their mind when they make those observations. So you're starting to ignite that curiosity. The next one, building explanations and interpretations. Now, as a teacher, this is your job. This is your main job, is to be asking questions. And this was something that I noticed at the beginning. My students were kind of intimidated when I asked them questions. They get defensive. So if I would go up and say, why are you using only 3 wheels? I don't know, because he told me to, or I thought that's what we were supposed to do. And it took me a while to reassure my students that I'm curious. I want to know what you're thinking. So again, whether you're a teacher, whether you're a parent, whether you're a principal or coach walking around a classroom, ask those questions. Be curious. Is this what you expected? This is always such a great moment when I would see my students stop and think, I don't know. Is that what I expected? That's activating the thinking. What do you think would happen if there was less force? Hadn't occurred to the student until I asked. Well, let me think about that. And it's amazing how much thinking gets activated. It's also wonderful as an observer, you can really do a lot of formative assessment by listening and recognizing, all right, so that student, first of all, has to understand what is force before they can answer that question, what would happen if there were less force. Student had to think about what expectations did I have before I can answer your question. It made teaching for me so much more fun when I could take a step back, when I could not have any expectations and simply ask and be an observer and watch as their thinking deepened. So giving my students the message that expect me to question. Next, reasoning with evidence. Now, this was an exciting place to get to in my classroom when, not at the beginning, this took a while to create a safe space, but where they knew that they had to provide evidence. It wasn't enough just to answer a question. They all knew to expect whether it might be from me or a peer. Well, why? Why do you think that? So these students were working on, there was a problem that they were looking at. And the question was about this box that had been built. And there was a flap that was opening and closing. And the person who was building it was using magnets. So the question was, what's going on with this flap that's supposed to be closing, and what might be the problem here? So the student, there was a team of them working on it. They answered, I think the magnets push the flap away because it might have an N and an N, north and north, facing each other. And when N and N are together, they repel, and they can turn around two of the magnets so there is an S and an N, and then they will attract. That's what they were saying, is that would make the door shut. Now, what was exciting to me about this is that when I was looking over their shoulders and just reading it, I hadn't even asked a question. They turned around and they said to me, can we use some magnets? We're pretty sure we know what will happen, but we want to check our thinking. Well, that was my answer below. Yes, yes, and yes. I was so excited that it wasn't enough that from their reading, from prior investigations, they were pretty sure they knew how magnets worked, and they were pretty sure that their answer was correct. But the fact that they wanted to go over, get some evidence, use those magnets to really check that, well, it showed me so many things about them, but that is such a deepening of their understanding for them to be able to say with great confidence, we can absolutely defend our response now. So that's an exciting moment when students feel so empowered and taking that extra risk. Now we're going to really check that and make sure that's correct. Next one, this is making connections all over the place to make student learning meaningful. This is something called a Freya model, which is something that I will often use in my class to deepen understanding of scientific vocabulary. So when a student, I know in my day, we would get a vocabulary word, we would look it up in the dictionary, we'd write down the answer, and by copying it out of the dictionary, and we were done. Not much thinking there, not much reflection there. So this They have the vocabulary words in the middle, and they do look up the definition of translucent, some light will pass through. But now next step, draw a picture. What exactly does translucent mean to you? This picture gives me a lot of understanding about their level of understanding. So you can see they've got the word sunlight and a whole bunch of arrows. Here's a curtain, and then showing that, oh, only some of those arrows are passing through. Also a great moment for me or the teacher or whoever's looking over the shoulder to say, well, tell me about, rather than the old teacher in me would have said, oh, that's a great picture, and moved on. As I started learning about, no, let me find out what is there. Let's not make any assumptions, asking them to explain it. And he was able to absolutely explain that, only some of the light's passing through. And then moving into making more connections. What are some examples? So this student had an example of a curtain that he could identify as something in his house where some light went through, but not all of it. And then he also identified the material bins, and he turned around and pointed to those on the back table. That was where we would store materials that we're going to be using for experiments. And he could explain that the material bins, and he actually held it up to the light where some sunlight could pass through, but not all of it when he held it up to the window. And then finally, this is another great way to help them connect more, is what are some related words? And he very quickly came up with the word transparent and was able to, there's the difference, that's going to let all the light through. Our next thinking move is considering different viewpoints and perspectives. Great one for every one of us to learn. And it's a great one. The earlier we start helping students understand the importance of that, of asking questions, encouraging questions, have students expect questioning, but also understanding that other people have things to say. So you may have one answer to a question, but somebody else may have either a different answer or a deeper answer. They may have more depth or something that they've experienced that will give you a different perspective. So one of the things that we use in the NOADM curriculum are these discourse frames. And this is only one part of them. We have multiple sheets of these, but this is helping students use that language, because sometimes students want to either disagree with someone or ask somebody to explain themselves, but they don't have the language. They don't exactly know how to do that. So this is really helpful when, for example, in helping understanding, I don't understand what you mean by blank. Could you give an example of what you mean by blank? I know for me as a learner, I need examples. I need, if somebody makes a statement, it's so helpful to me when you can say, well, give me an example of that. I'm not sure I understand your question. Could you rephrase that? That seems so simple to us as an adult, but that often does not occur to a student to ask in that way. So giving them the language to be able to question their peers and question adults. It used to make me really feel so sad as a teacher when I might find out maybe days later, or maybe from a parent, that, my student really didn't understand what was going on, didn't understand the directions, didn't understand what he or she was missing. And my feeling just horrified that, why didn't they ask? Well, they didn't necessarily have the language, or the courage. That felt like too big of a risk. So to start to create a classroom where that kind of dialogue is expected and accepted. Capturing the heart and forming conclusions. Now, in this one, this is where you are helping students look at the big picture. And let me give you some background on this, because I thought that this was a really powerful learning for this group of students. So they were growing plants, and their question was, do plants need soil to grow? As long as we give them water and sunlight, are we okay? And so their conclusion, our hypothesis was incorrect. After 10 days, the average height of the plant in the soil was 20 centimeters, and the plant in the cotton was 5 centimeters. So they had used soil for one container, cotton balls for the other. The cotton plants were not green. Soil was better because it has nutrients that the plants need. Now, when we were talking, the students were saying, in our hypothesis, so their hypothesis that they created, we said the plants would grow the same height, whether they were in cotton or soil. We thought that since they were both getting water, air, and sun, they would be the same. We should have paid more attention to our research. So take a look at their research. In their research, it says plants need water, sun, and nutrients and air to grow. Now, this simply came with my just questioning, and this came at the end when they were kind of upset because their hypothesis was incorrect, and being able to push that thinking. Well, backing up to the beginning of the investigation, and for them to get that, we should have paid more attention. And also for them to understand that was the great learning. They learned a lot, and they were able to really embrace that. Wondering and asking questions. This was something that I would do a lot at the beginning of a new unit, the first read protocol. So with their team, they would simply explore the science reader and discuss what makes them curious as they explore pictures and diagrams, and then note 3 things that they are curious about. And I would do that at the beginning of the year to kind of set up those expectations that before we dive into it, let's look and let's wonder and let's ask lots and lots of questions. And this was just one I grabbed because I liked these questions a lot. Are all diamonds formed deep within the earth? And again, this was just kind of coming from quick glances at pictures, my favorite. I'm curious what experiment we are going to be doing. And that kind of excitement, I'm looking beyond whatever else is going on and thinking about what are we going to do, which led to a great discussion within the group when, as a teacher, I sat down, I said, well, what do you think? What does everybody think we're going to talk about? And there was a lot of great excitement and great connections and great exploring of the ideas. Well, taking a look at this, maybe we'll do that. And then the other one, is the Hope Diamond 1 billion years old? There was a state, and I was able to asked as a teacher, well, why are you saying 1 billion? And they quickly pointed to, there was an image, and it just stated that the Hope Diamond was very, very old. So they went to 1 billion. But again, good wondering. Uncovering complexity and going below the surface of things. These are 2 different this first one was an engineering prototype. So they were engineering filtration devices, and they had lots and lots of materials to do that. And they had to get, in order for their prototype to be successful, they had to get their water to a certain grade. There was A, B, C, and D. And their water was polluted. And they had beakers that they would examine after their water had gone through the filtration system, they would hold it up to the A, B, C beaker. And in order for their prototype to be successful, it had to be at least a B grade, which showed a lot of pollution had been filtered out. So this team asked, because theirs did not filter very well. Question was, I'm curious about how Jay Reese's group got their water so pure. Let's find out what materials they used for their filter. Excellent question. And what I also really liked was their assumption that they could go do that. They could go ask another team for help, because they were confused. They weren't sure why things hadn't gone very well. And to be able to seek out more assistance in that, and to be able to understand there's something about the materials that we chose that didn't work well. So let's get more. The second prototype was they were making a roller coaster, and they were questioning it. Things weren't working well. There was supposed to be marbles that were staying on the roller coaster. And they said, this prototype works, but I wonder if it could be more efficient with some changes. Maybe we could make it way less somehow. This kind of thinking is so great, because they weren't ready to stop at, well, it works, but wondering, could it be more efficient? And that's such a powerful kind of thinking that's exciting to see in a team of students, that they're not just saying, how could we make it better? They're actually going a little bit further and thinking about, if it weighed less, what might that do? Oops. All right, those are the thinking moves that I'm giving you to reflect upon. What I would love to see everyone do is try it. Think about that. You'll be getting a copy of you'll be able to download the thinking moves. You'll be getting a copy of this video, this slideshow. And I hope that you'll try that in your classroom. And I'd be really, really excited if you wanted to drop me an email, ask me any questions, or let me know about some success that you might have. Thank you so much for your time.